in this question, what we need to realize is that the triangle here is actually a right angle triangle. That's the first thing to realize in these questions A and B. How do we know it's a right angle triangle? There's this symbol. This symbol is the symbol of the right angle, and we know the right angle is 90 degrees. Any triangle that has one of its interior angles 90 degrees is a right angle triangle. So we have it here, we have it there. Then the next thing is to now remember one of the fundamental properties of a right angle triangle, which is the Pythagoras theorem. The Pythagoras theorem says that the hypotenuse squared is equal to the sum of the square of the other two sides that we can call the base and the height. So if we call this one here the base, all right, then that's the base, this is the hypotenuse, and that's the height. So by the Pythagoras theorem, the hypotenuse square is equal to the base square plus the height square. Now, this is the theorem that is going to help us to be able to calculate the value of x. So let's go ahead and put the expression for hypotenuse. The hypotenuse is x plus 2. So we square it. The base is x plus 1. We square it. And then the height is x. We also square it. This is the equation that will help us solve the value of x. Solve for the value of x, sorry. Now, x plus 2 all squared simply means x plus 2 multiplied to itself. The same thing for x plus 1. It means x plus 1 multiplied to itself. Okay, so how do we do this? We open out this parenthesis. This x will multiply to that, and will also come and multiply to that. Then later on, we'll take this other element and we'll do the same thing. This 2 will multiply to x and will multiply to the 2. So let's begin. X multiplied to x is x squared. X multiplied to 2 is 2x. We're through with this member. We'll now go to this member. We'll do the same thing. 2 multiplied to x is 2x. 2 multiplied to 2 is 4. So we're through with the expansion of the left-hand side. Let's move on to this other expansion. X multiplied to x is x squared. X multiplied to 1 is x. 1 multiplied to x is x. 1 multiplied to 1 is 1. Okay. Now, if we look here, we see these are like terms. This one is also a like term to that, and these are also like terms. So we simplify like terms. So we have x squared plus 2x plus 2x, 4x plus 4 is equal to, now x squared plus x squared, there are two of them, so we have 2x squared. X plus x, two of them, so we have 2x plus 1. All right. Now looking, we see that the left-hand side is a quadratic expression. The right-hand side is also a quadratic expression. Remember, a quadratic expression is a polynomial of degree 2. All right, degree 2 simply means the highest power of the variable is 2. So now it makes sense if we can bring everything to one side and have 0 on the other side. Now I'll prefer to remove everything from the left-hand side to the right-hand side, because here I have 2x squared and here I have only 1x squared. So I don't want to be working with negative expressions. So I want to carry everything from the left-hand side to the right-hand side so that I can have 0 on the left-hand side. Now this is 1x squared. Going over there will become minus 1x squared. So say 2x squared minus 1x squared is 1x squared. And that's how I write it. 1x squared is just x squared. This is positive 4x. When I take it that way, it will become negative 4x. So here we have 2x. So 2x minus 4x gives us negative 2x. This is positive 4. Taking it all that way, it becomes negative 4. So we have 1 minus 4 is negative 3. So this is the quadratic equation now that we have to solve for x. It's a quadratic equation, so we expect it to have two solutions. Any polynomial of degree 2 must have two solutions. So we can use either any of the methods in solving a quadratic equation, be it factorization method, using the formula, or completing the squares. So let us use the formula method. All right. With the formula method, we need to collect our elements. A is the coefficient of the x squared term. A is 1. B is the coefficient of the x term. This is the x. The coefficient is -2 and not 2. So write -2. And C is the constant, the term that does not carry the variable x. So the constant is -3 and not 3. All right, so we take our time, we'll make sure we collect this information carefully. Now the formula says the solution is x equals -b plus minus the root of b squared minus 4ac. All of that divided by 2a. So let's put our elements here carefully. -b, b is -2, plus minus the root of b squared, b is -2, so we're going to square that, minus 4 into a times c. All of that divided by 2a. So this means x is equal to negative gives us +2, plus or minus the root of -2 squared. -2 means -2 times -2. Negative times negative positive. 2 times 2, 4. All right. So that gives us +4 here. Then negative times negative positive. So 4 times 1 times 3 is +12. All of that divided by 2. So clearly now from here we see that the value of x will be 2 plus minus root 16 all over 2. So we have x is either equal to 2 plus 4 all over 2, which is 3, or x is equal to 2 minus 4 all over 2, which is -1. So the possible values of x are x equals 3, x equals -1. Now, that means that here we can either have x equals to 3 or we have x equals to -1. But remember, x represents this length, and we don't measure lengths. Lengths don't have negative values. We can't measure any distance between 2 points and we write it as a negative value. So from that reasoning point, we'll dismiss the value x equals -1. -1 will be rejected. And so the only answer that we have here is x equals 3. Okay. Now we can always go ahead and check. We can always check to see if it is correct. X equals 3 as our answer. Let us put it in our Pythagoras theorem and see if it is true. Now the left hand side is x plus 2 squared. Base is x plus 1 squared. Height is x squared. Now let's put the value of x there. X is 3. 3 plus 2 squared. 3 plus 1 squared. 3 squared. Let us check to see if the left hand side will give us the same result as the right hand side. Now this is 5 squared. This is 4 squared. 3 squared. 5 squared is 25. 4 squared is 16. 3 squared is 9. So we have that the left hand side is actually equal to the right hand side. So conclusion, the value of x is 3. The value of x is 3 for question A. Now you can try out question B. You see that it's also a right angle triangle, and so we can apply the Pythagoras theorem again. All right, so give it a try and then you come and check your solution with what I have to propose. Okay, hoping that you have done it. Now let us see what I have. Again, the Pythagoras theorem remains the same. Hypotenuse squared is equal to the square of the base plus the square of the height. In this right angle triangle, the longest side, that is it there, everyone can identify that. And so that is our hypotenuse, and this one is our base, and this one is our height. So let's put the different elements in the right positions here. So hypotenuse is 2. So we have 2 squared. Base is root x plus 2. The base is squared, and the height is x. So we square it. So this is the equation that we have to solve. So let's handle the parentheses first. If of course 2 squared is 4, that's it. And then the parentheses, we know that the function, the square function, always cancels out the square root function. So they will cancel out, and we are left with x plus 2 plus x squared. We have this equation to solve for x. It's clearly a quadratic equation. So again, like we did in the first exercise A, let's have 0 on one side. Okay, let's take this positive 4 from the left hand side to the right hand side. So we have, I'm rearranging at the same time, x squared plus x plus 2, now minus 4. This positive 4 going this way becomes minus 4. So we have 0 equals x squared plus x minus 2, because 2 minus 4 is minus 2. So this is the quadratic equation that we end up in our question B to solve for x. Again, let's use the formula method. The coefficient of the x squared term is 1. The coefficient of the x term is 1. And the constant term is negative 2. So we can now use our quadratic formula, which is x equals minus b plus minus the root of b squared minus 4ac all over 2a. So this gives us negative 1 plus minus the root of 1 squared minus 4 into 1 into negative 2. All of that divided by 2a. So this gives us x equals negative 1 plus minus 1 squared is 1. Negative is plus. So we have 1 plus 8, because 4 times 2 is 8 plus 1 is 9 all over 2. So it means x is equal to negative 1 plus minus 3 all over 2. Okay, so that therefore means that x is equal to negative 1 plus minus 3 all over 2. I just want to repeat that expression. It therefore means that x equals negative 1 plus 3 all over 2, which is 2 all over 2, which is 1, or x is equal to negative 1 minus 3 all over 2, which is negative 4 all over 2, which is negative 2. So these are the two possible values of x that can go for that Pythagoras expression for the triangle B. Again, just like in question A, the length between 2 points cannot have a negative value. And so the value x equals negative 2 is discarded. Conclusion, our answer is x equals 1. All right. We can also check that. We can also check to be sure that this is true. All right. If we take our Pythagoras theorem again, we had 2 squared. The hypotenuse squared is equal to the square of the base plus the square of the height. If x is 1, let's go ahead and see if the left hand side will give us the same result as the right hand side. So we have here 4 is equal to the root of 1 plus 2 is 3. So root 3 squared plus 1 squared. So we have 4 here. Remember, square cancels square root. 3 plus 1 squared is 1. So we end up with 4 equals 4, which is a true statement. Therefore, the solution, or the value of x for the triangle in question B, is the value x equals 1.